Hello DP Maths class. This is the first video we're going to use in order to set up the flipped classroom model to help you all learn better. The first video is about the idea of quadratic optimization. What it is using the quadratic equation to find the most optimal values or the best solutions to a particular situation. So let's go over some fundamentals we've already learned. So this is all about the vertex or turning point of our parabolic curve. Now above us here we have the general form of our equation. Y equals ax squared plus bx plus c. Now we've already learned that if a is a value greater than 0, we're going to get our minimum turning point at the value when x is equal to negative b over 2a, as we see here. So this is a minimum turning point, as we described by concave upwards. This is the point where the values of y change from decreasing to increasing. Same though, if we look at the same equation again, but now the value of a is less than 0. The turning point, or the vertex, will still occur at x is equal to negative b over 2a. But now it's a maximum turning point, or concave downwards. So this is the point here where the values of y go from being increasing to decreasing. So what we want to do is we want to use the information from the vertex to determine what is the best solution or the most optimal solution for a particular problem. So what we have to ask is there some sort of situation which we can describe somehow using a quadratic equation? If we can represent or model some sort of situation by this equation, we can find the most optimal solution by looking at what the vertex tells us. Here are some examples of this. You may be running some sort of manufacturing company, and there are costs involved with producing whatever you make. Now, if the cost of your production is modeled by some sort of quadratic equation, maybe we could say, what's the lowest cost of the manufacturing we need for that company? Because of course, if you lower costs, it's a way to increase profit. Another one might be, there might be a type of plant in a certain ecosystem, and its growth in that ecosystem is again represented using some quadratic equation. So we could figure out the highest possible population of that species of plant life in that ecosystem. There are a whole range of different things we can determine simply by saying, is it a situation that we can model somehow with a quadratic equation? So the next video you're going to come after this is actually going to be me doing an example of how we would find such an optimal solution.